take a look at page, where are we at? Oh, page 12. 12. Okay. Today we're actually going to start, and bad news is we've already talked about stoichiometry, but we get to do stoichiometry again. So yes, we're revisiting your favorite S word. I'm not going to put the notes up on the board because you have them in front of you. Now, who can tell me, and they're right there in front of you, there are 4 steps for stoichiometry. What's the first step? Write a balanced equation, good. Step 2 is to change what's given into moles. So oftentimes it'll be grams, sometimes it could be a lot of information within the PV equals nRT, and we solve for moles this way. So there's 2 options there. Step 3, we can use the mole ratio. So whatever we start with, get that converted to moles, and then we'll cancel it out, and then we'll be looking for something else, obviously. And then the last step is to convert to the desired units. So let's just go right to the example or the practice problem on the bottom of page 13. Okay. So again, really there's nothing new. We'll still be using PV equals nRT. The constants are given there, and we just have a little bit of an addition there. Yeah.
So we're going to get more practice with what we've been doing the past, like this whole packet?
Yeah, next week, Monday, Tuesday, is a review, and then the test will be on. Looking at practice problem number 1 at the bottom of page 13, the question reads, it says, what temperature will water vapor form? So we have water vapor being formed, and it wants to know at what temperature. When 20 grams of hydrogen, how do I represent hydrogen?
H2.
Nice, good. So we have 20 grams of hydrogen, so we'll put 20 grams right above it. Reacts with oxygen, and it doesn't say anything about how much oxygen we have, so this is not a limiting reactant problem. That's tomorrow.
Oh my gosh.
All right. Also, the question reads on, it says, the water is formed at a pressure, so we have a pressure at 95 kilopascals, and the volume is 17 liters. Okay. So we're looking for the temperature. We have the pressure, we have the volume. So let's go ahead and go through the steps. Step 1, is this balanced? No. So we need a 2 in front of that and a 2 in front of that. So we have our equation balanced. Step 2, change what's given, or what's given to give us moles. So we'll take the 20 grams and convert it into moles. So 1 mole of hydrogen, 2 times 1.008 from the periodic table. And that's all step 2. Step 3, use the mole ratio, so we get rid of moles of hydrogen. So we'll put moles of hydrogen down there. And we're looking for moles of water, because what we have is we have the pressure, we have the volume, we'll essentially have the number of moles, and we'll have the constant, so we're looking for T. So we really need to know how many moles we have, so we'll stop right here. But what numbers go here and here? 2, because from the balanced equation. So that'll give us our number of moles. So 9.92, anybody else get that for moles? So we're looking for a temperature, so we need to rearrange the equation. So how do I isolate T all by itself?
Divide N and R.
Divide N and R on both sides. So now I've got PV over NR is equal to T. Because the pressure and volume are given, the number of moles we just found, and the R's are. Now be careful that you're using the correct R value.
What is that?
What's that?
What is it again?
Yeah.
Which one?
I have a question about that.
What? What do you have a question about?
It's 8.31.
Why?
Because it's kilopascal.
Good. So we're looking at the pressure to determine which R you should use.
So we look at the pressure of the problem.
Correct. So here I gave you kilopascals, so we need to use that one.
Okay, so we put the moles K on top.
So we'll go, yep. And the volume is 17. Number of moles we said was 9.92. R is the 8.31. And mole Kelvin goes on the opposite side. So should have that arrangement. So moles can cancel, kilopascal can cancel. Why did I put liter there? It's liters. Liters can cancel, and we're left with Kelvin. Okay. 19.6. So 19.6 Kelvin, is that cold? Yeah, number 2 at the top of page 14. It says when 75 grams of phosphorus pentachloride, how do I write phosphorus pentachloride?
PCL.
PCl5, good. And it's how much? 75 grams? Okay. Decomposes, arrow. When heated, it forms what volume of chlorine gas? So what volume? It says the other product is phosphorus trichloride, so PCl3. Don't worry about charges when you see the Greek prefixes. So don't sit here and go, +5, no, we don't care about charges because it's non-metal with non-metal. I think that's all the information you give. Oh no, we have 200 degrees and the pressure is kilopascal, 150. What was that?
Should we convert that?
Yeah. Eventually we'll do it. Okay. All right, so step 1. Balanced as written, good. Step 2, change that 75 grams into moles. So 1 mole of PCl5.
I got you.
Yeah?
He said, I got you, hold on.
208.22.
208 point what?
22.
22, thank you. And that's step 2. Step 3, get rid of the moles of the phosphorus trichloride, pentachloride, and we're going to moles of chlorine. And again, the reason why we're going to moles of chlorine is because we're looking for the volume, we have the temperature and the pressure, so the other variable is N that we're looking for. And yeah, these are 1 to 1. So 208. So 0.36. Let's say 360. Okay. And so we're looking for the volume. So divide pressure on both sides. So V is equal to nRT over P. And then plug them in. Which bar should we use? Good, because we have kilopascals again. So kPa liters, mole Kelvin. Temperature, we did 473. Pressure was 150. So kelvins are gone, moles are gone, kPa gone, we're left with liters. So at least the units are set up correctly. So around 9.44 ish. All right, the next part, add STP. So what are the conditions?
0 degrees Celsius and 1 degree.
So the temperature is 0 degrees Celsius. Actually, it's 273. And the pressure, next page, right on, oh yeah, the 4 is part of your homework. So the pressure is 1 atmosphere. Now, what I also didn't tell you is that if we have 1 mole of a gas, and what's really cool is it doesn't matter what the gas is, so it could be really light hydrogen or really heavy radon. Any gas at this temperature and this pressure will have a volume of 22.4 liters. Now you're sitting here going, how in the world did he get that? Well, we can find the volume by rearranging the equation and plugging these values in. I'm sorry, other than the volume. We can plug these values in and it will give us 22.4.
Hey, that's that number you said you remembered.
What's that?
That's the number you said you remember in the video.
What number did I say to remember?
22.4.
That's if you want to. I'm not forcing you to. That's your option. If you want to do it, that's fine. So whenever we're at STP, for every mole of a gas, you'll have a volume of 22.4 liters. So let's say, here we go, we had 2 moles of gas at STP. What's the volume? 44.8, okay. What if we had a half a mole?
11.2.
There you go, you got it. Okay, so we can treat that as kind of like a dimensional analysis conversion. The bad news is this is only true at this temperature and this pressure, okay? Now, if you like it the old way, okay, you can always use PV equals nRT for every problem that we're doing. So I'll show you both ways on how to use or how to calculate these things at STP. So as long as you're showing complete work, I'll be happy. So let's take a look at the first example. Page 16, practice problem number 1, near the middle of the page. It says, how many grams of carbon dioxide gas forms within a 400 liter container at STP? So it wants to know how many grams in a 400 liter container. Okay, so what do we know from this problem? Well, let me ask you this before we start. Is this a stoichiometry problem?
Yeah.
I hear yes and I hear no.
I have no.
Not everything's stoichiometry. Why is it not stoichiometry? We only have one thing. Good. So we don't have the things that make up carbon dioxide. We know what makes up carbon dioxide, but it doesn't. The question doesn't say it. In other words, generally you'll be given information about one thing to find out something else. Okay. So this is not a stoichiometry problem, unfortunately. I know. I agree. Thank you. So here's one way that we can solve it. Start with what you know. And if you remember the conversion at STP, where 1 mole of a gas equals 22.4 liters, you may do that. So we can use that conversion, and this is carbon dioxide, is 22.4 liters. So if we stop right there, that'll tell us how many moles we have. But the question wants to know how many grams, so you go one more step. So 1 mole of carbon dioxide is 12.01. 2 times 16, and we'll get a value for 786.
Yeah.
Somewhere in here. Okay. So 786 grams of carbon dioxide. Now that's one way to work it out. The other way, do it the old-fashioned way. So we know that we have our pressure volume, and we're looking for N in this case. So N is equal to PV over RT. Okay. We know our pressure is 1 atmosphere. So you have 1 atmosphere of gas.
I thought it said
Go ahead.
how many grams. Isn't that answer?
Correct. I'm showing the other way. Yeah, so there's 2 ways that you could work this out. Some people will want to use PV equals nRT. They're just like, okay, I've been using it this whole topic. I want to continue to use it. And that's fine. I'm just showing the other option. And then the volume was 400 liters. The R, since it's at atmospheres, 0.0821 mole Kelvin. And then the temperature is 273. So that'll give us our number of moles, which is 17 point, is that 8.6 or say, we'll say 8.6 moles. What? And then convert the moles to grams. So the 44.01 grams per mole. And it should give you the same answer. Okay. So what I'm saying is you can show it this way as your complete work, or you can show it this way as your complete work. Okay. So I'm giving you the option. And that's the nice thing about chemistry. There's more than one way to work these things out.
Oh, I think I know how to do
Okay.
it.
Number
Number 2?
two.
I think I can do
Want to do it?
it. Up there?
Yeah.
Can I go over and check?
I was thinking about this. It's 19 grams, and corn itself is 19, just as full of gas. It's 2 times the answer.
I did that, you know,
You don't stick one half.
19 times 4 divided by 38. 25.
It's like the simplest Yay!
Wait, is that right?
Yeah, that's good. I know, right? And nothing wrong with doing it that way? The other way, does anybody want to do it the other way, or
I'll do it for you.
the other way?
You want me to?
The PV equals NRT one?
I'll do it.
Do it.
Come on, Keaton.
Do it.
You want
But
me
you
to-
gotta leave her work up there, so we can check it.
Yeah, right, small.
Oh, I thought you were gonna bring in the flour, cause I already tried to imitate it.
Oh, no.
They did?
And you didn't. Sorry, right
Hmm? We're going for volume, right?
Yes.
I don't know what I'm doing, okay?
I'll give you a heads up. The first part that she did, you have to do. You have to find out how many moles you have. So the last step is the PV equals NRT.
I have 0.5 moles, right?
Yes.
Okay, good.
Say it to the video. 19 divided by 38 equals 0.5.
I have purple glasses on, Craig. Why would you do that to me?
I can't wait to watch this video.
I'm on camera.
Don't nobody share that you on camera. Act like you about to be famous or something.
This will be on the World Wide Web.
OMG.
YouTube. Oh, this is my first time on YouTube.
Really?
Yes.
That you know of?
Well, okay, yeah, I guess.
Oh my gosh, I get to do this.
I don't know what to expect
when we get into this. We have a little holder thing.
You can look up to see what it is as well. Go on top right corner. Yeah, the 4s and 5s are homework, so if you're waiting for Keaton to finish here.
That's rude.
Oh boy, I'm telling you, when I get done editing this, you're gonna look good.
You gotta leave the part about my glasses.
I gotta leave the part with the glasses or without?
Yeah.
Okay.
See that? Did it in my brain.
Impressive.
How do you find out what it is?
How do you find the moles? Alright.
Sorry.
What he didn't show you was this divided by this. So really it's this part right here. You have to show that before you plug them in.
I just forgot to multiply 19 by 2.